We're going to move on to section 3 of circles. We're looking at angles and special segments in the circle. A little bit shorter section here. Start out with the perpendicular bisector theorem. Whenever we have a radius of a circle, so you can see here we have the radius of a circle, it is perpendicular to a chord. Remember, a chord is a line that goes through the circle, touches both ends, not necessarily in the middle, if and only if it bisects the chord and its arc. So this is only going to be perpendicular when these two halves are the same length. And by the same idea, if these two are the same length, we will know that it intersects at a perpendicular, at a 90-degree angle. So if we were to write these two things, we have chord is bisected. We also have chord perpendicular to radius. And if you remember the words if and only if, that's the double arrow. That means that we have a two-way statement. So that means that if we know that the chord is bisected, then we also know it's perpendicular to the radius. If we know it's perpendicular to the radius, we can go backwards and say the chord is bisected. So either one of those two pieces of information helps you prove the other. If we look at this example here, we're given circle Q. We're told that WX is 10. We're told that the arc WPR, this whole thing here, is 150 degrees. Then we need to find the arc WP. Now the thing that we didn't talk as much about here is going back up to the last part. It says it bisects the chord and its arc. So we could even add a third thing here. It says arc is bisected. So any one of those three prove each other. Here we have the arc of 150. If this is a 90-degree angle, so we have the chord is perpendicular to the radius, we get the other two things. So we get the fact that WP and PR are each going to be 75 degrees. We also get the fact that these two pieces are the same length, making XR 10. So when it asks, in the first one, measure of WP, what is that arc? It is 75 degrees. WR is the whole length from W all the way down to R, the whole length of the chord. It's going to be 10 plus 10 is 20. And then we're told if QX is 5, what is QP? QX here is just this short little piece. And we're told that that is equal to 5. And it wants to know what is the whole length of QP. One thing we can consider here is that we can make a right triangle. So since we have a right angle, we can go and take this 5 and make that a side, and this 10 over here and make that a side. I'm actually going to rewrite the 10 so that it's a little clearer where it actually belongs. 5 up there, 10 up there, and then we need to figure out what that unknown side is. The reason that unknown side is useful or significant is because that unknown side is a radius, and so is QP. So if we can find that unknown side, we can also find the whole length here, because this is also going to be a radius. So both of those are radii, therefore they are both the same length, so that we can use Pythagorean theorem here to solve for that. We have 5 squared plus 10 squared, because we have our two legs, is equal to our unknown side squared. So 25 plus 100, which is 125, is equal to our unknown side squared. So square root both sides, and we know that the square root of 125 is going to be our radius. So QP, also a radius, has a length of square root of 125. You could round that and get a decimal, but keeping it exact is also a good way to do it.